Has matrix multiplication ever left you confused, frustrated, or ready to flip your textbook? Don't worry and stick around, because we're going to show you a simplified method to multiply matrices. What are we going to cover here? A step-by-step tutorial to show you exactly how to multiply any two matrices. No shortcuts, just solid understanding. The most common errors students make, so you can dodge them like a pro. And 3 quick practice questions at the end to lock in your learning. We guarantee this is the best crash course and covers everything you need to know. Hit like if you enjoyed the video, or let us know in the comments how we can improve. Let's get started and clear the concept first. Stick around. We'll cover the common mistakes right after you've got the method down.
Let's see the multiplication of matrices. So if you have two matrices A and B, they are suitable for multiplication, as in A multiplied by B, if the number of columns of A is equal to the number of rows of B. So A multiplied by B is only possible when the number of columns of A is equal to the number of rows of B. Now, see this example here. A here is of the order 2 by 3, so 2 rows and 3 columns. And B here is of the order 3 by 3, so 3 rows and 3 columns. The number of columns of A is equal to the number of rows of B. So A multiplied by B is indeed feasible. Now, let's see how the multiplication actually happens. So let's take a look at a simpler example first. Let's say matrix A here is 1 and 2. Let's say matrix B here is 1 and 3. So we want to find A multiplied by B. So first let's see if they are suitable for multiplication. Matrix A is of the order 1 by 2. Matrix B is of the order 2 by 1. So matrix A has 2 columns and matrix B has 2 rows. So the number of columns of A is equal to the number of rows of B. So A and B are suitable for multiplication. Now, to actually multiply A and B, what you'll simply do is multiply the rows of A into the columns of B. That's really about it. So you'll multiply 1 and 1, and add it with 2 multiplied by 3. And the resultant matrix will be 1 plus 6, which is this here. Now, a very handy way of a trick of finding the to confirm the order of the resultant matrix. So 7 here is of the order 1 by 1. To actually see if this is actually the correct order, you'll just simply find these two numbers. The resultant matrix must have the number of rows of the first matrix, which is A here, and the number of columns of the second matrix, which is B here. So 1 by 1. Let's see a more advanced example. Let's find A multiplied by B. First, let's see if they are suitable for multiplication. So A here is of the order 2 by 2. B here is also of the order 2 by 2. So the number of columns of A is equal to the number of rows of B. So they're indeed suitable for multiplication. And the resultant matrix will be of the order 2 by 2, because it will have the number of rows of A and the number of columns of B. Let's just see. See here, this matrix is of the order 2 by 2. Now, how did we find this? Simple. You'll first multiply the first row of A into the first column of B. So 2 multiplied by 1 plus 3 multiplied by 6. Now the second element, simple. You'll first multiply the same first row of A into the second column of B. So 2 multiplied by 7 plus 3 multiplied by 4. Now, this is getting a bit messy here. Let's erase these lines. Now the third element of the resultant matrix, that will be found by multiplying the second row of A and the first column of B. So 1 multiplied by 1 plus 5 multiplied by 6. Now the last element, of course, will be found by multiplying the second row of A and the second column of B. So 1 multiplied by 7 plus 5 multiplied by 4. This is the answer of A multiplied by B.
All right, before we wrap up and proceed to practice questions, let's clear up some classic blunders students make when multiplying matrices. These slip-ups can mess up an entire answer, even if your steps look neat. First, mixing up the order. Matrix multiplication is not like regular multiplication. A times b is not the same as b times a. Always remember the condition. The number of columns in the first matrix matches the number of rows in the second. Otherwise, boom, undefined. Second mistake, treating it like matrix addition. Some students just add the numbers in the same positions. That's a big no-no. In multiplication, you multiply across rows and columns. It's all about those dot products. And finally, getting the result dimensions wrong. Remember, the size of your answer comes from the outer numbers. If you're multiplying a 3 by 2 by a 2 by 3 matrix, your result is 3 by 3. Not 2 by 2, not 2 by 3. 3 by 3. All right, you've seen the method, spotted the mistakes. Now it's your turn. Here are 3 practice questions to test your skills. Don't miss this chance to put your learning into action. If you can solve all 3, we're confident you can handle any matrix multiplication problem. Give them a shot before checking the solutions. Or better yet, drop your answers in the comments and see how they stack up against others. Let's kick off with something simple to check your foundation. This question is all about the basics. Can these 2 matrices be multiplied? And if so, what will the dimensions of the result be? What is the answer? Pause the video right now, grab a notebook, and work it out. Drop your answer in the comments below. And hey, don't be shy. Even if you're unsure, it's all part of learning. Check what others have posted, then hit play, come back, and we'll walk through the solution together. Resume when you are ready. Watch the video step by step and compare with your answer. Pause the video if you need more time to understand the calculation. Let us start with row 1 of matrix A and multiply it with all columns of matrix B, one at a time. Pay close attention to the red rectangles. We start by multiplying row 1 of matrix A with column 1 of matrix B, and write the answer as the first entry in the first row of the resultant matrix. Then we multiply row 1 of matrix A with column 2 of matrix B, and write the answer as the second entry in row 1 of the resultant matrix. After this, we multiply row 1 of matrix A with column 3 of matrix B, and write the answer as the third entry in row 1 of the resultant matrix. We have now completed all 3 entries in the first row. Let us move to row 2 of matrix A and multiply it with all columns of matrix B, one at a time. Pay close attention to the red rectangles. We start by multiplying row 2 of matrix A with column 1 of matrix B, and write the answer as the first entry in the second row of the resultant matrix. Then we multiply row 2 of matrix A with column 2 of matrix B, and write the answer as the second entry in the second row of the resultant matrix. After this, we multiply row 2 of matrix A with column 3 of matrix B, and write the answer as the third entry in the second row of the resultant matrix. We have now completed all 3 entries in the second row. Lastly, let us move to row 3 of matrix A and multiply it with all columns of matrix B, one at a time. Pay close attention to the red rectangles. We start by multiplying row 3 of matrix A with column 1 of matrix B, and write the answer as the first entry in the third row of the resultant matrix. Then we multiply row 3 of matrix A with column 2 of matrix B, and write the answer as the second entry in the third row of the resultant matrix. After this, we multiply row 3 of matrix A with column 3 of matrix B, and write the answer as the third entry in the third row of the resultant matrix. We have now completed all 3 entries in the third row. That was the difficult step in this process. If you have done this right, then you have mastered the concept. Let us now simplify the matrix by multiplying the entries and adding them in the corresponding places in the matrix. Pay attention to the red rectangles to understand this step. You can complete other entries by the same method. Pause the video here if you need more time to compare your answer. The last step is fairly simple and just involve adding the numbers and writing them in the final resultant matrix. Nice work on the first one. Now let's take it up a notch. This second question is all about applying what you've learned. We're throwing in a few bigger numbers and expecting you to do the full multiplication. So, double-check your rows and columns, align those elements carefully, and don't lose track of your sums. Pause the video, solve it step by step, and as always, drop your answer in the comments. Compare with others, then hit play, and join me for the full solution breakdown. Resume when you are ready. Watch the step-by-step solution and compare with your answer. If you are confused, go back to practice question 1 for help. Here it is, your final challenge. This one brings everything together. The dimensions work out, the numbers are trickier, and you're expected to calculate the entire resulting matrix. Focus on accuracy, row by column, one entry at a time. If you've made it this far, you're already ahead. Now it's time to prove you've mastered the method. Pause the video, give it your best shot, and drop that final answer in the comments. Then check what others got, and come right back for the full walkthrough. Let's finish strong. Resume when you are ready. Watch the step-by-step solution and compare with your answer. If you are confused, go back to practice question 1 for help. Great job! We are proud of you. Here is what we have learned. A step-by-step tutorial to show you exactly how to multiply any two matrices. The most common errors students make. And 3 practice questions. Hit like if you enjoyed the video, or let us know in the comments how we can improve.